In this video, we'll be going over Chapter 7, Section 1, where we look at understanding solutions. A solution is a mixture that is very well mixed and contains a solvent and at least one solute. When we're talking about solvents and solutes, they're hard to remember, so you're going to want to make sure that you figure out some little mnemonic or some other way that helps you remember which one is which. The solvent is the larger amount. Okay, and the solute is whatever is in the substance that's going to be dissolved and is in the smaller amount. So solvent is big, solute is small. The solute is dissolved by the solvent. Okay, there's a lot of S's going on in these words. Okay, solutions are when things are dissolved evenly and they have the same properties throughout the entire solution. Okay, they have little particles of dissolved solute in them, and they have the same properties throughout the entire solution. Okay, in a lot of cases, the solvent is going to be water, but there are solutions that don't have water. Some examples on the side here. So an example of a solution that is both gas and gas mixed together. The air is oxygen, but it also has other gases like nitrogen in it. So that's an example of a solution with gases. With liquids, an example would be antifreeze. It has ethyl glycol and it also has water. An example for a solid in a liquid for a solution would be like ocean water, right? That has sodium chloride as well as water mixed together to make that salt water. But they're mixed very evenly. The salt is dissolved into the water. You cannot see the particles, so it is a solution. So again, a solution has a solvent and a solute. The solvent is the large amount. The solute is the small amount. Other than solutions, there are also two other types of mixtures, colloids and suspensions. They have different properties than a solution. A colloid is going to be a mixture that has undissolved particles, but they don't settle out, and they're very, very small, so you can't see them, but they easily scatter light. So like milk isn't see-through, right? Because the particles within the milk are reflecting the light around, and so you can't see the particles and you can't see through it. So it's going to be an example of a colloid. But if you let milk sit for a long time, it doesn't settle out to be different layers. Whereas for a suspension, those are going to be particles that can be seen and easily separated by settling or filtration. They don't always have to be seen. So an example of a suspension would be like a snow globe. Those ones you can see, right? When you shake the snow globe, the particles float around. When it sits for a long time, they settle out to the bottom. So that's going to be a suspension when they're floating around in it. If you think about the Tanana River is a really silty river. And so if you were to take a jar of water from the Tanana River and set it somewhere, if you leave it for a couple of days, the silt is eventually going to settle out of that water and just kind of pile up in the bottom. So you would have water on the top and then like a sandy, muddy mix down on the bottom. So that's a solution because as the water is churning and moving, it's suspending that silt in the water. So it's a suspension, but if you let it sit for a while, it's going to settle out. Colloids, they don't settle out. The pieces don't come apart. They don't end up at the bottom. Suspensions, the pieces will settle out and eventually go down to the bottom if there's no more movement of the fluid. When particles in a solution are being dissolved, they're going to be broken apart in this manner. So if you look at these pictures, in the first one, we have a pile of salt and we have water up at the top. Then you can see how the water is kind of pulling on the pieces of the salt and breaking them apart and then surrounding them with water molecules until there's no more salt pile at the bottom. And so those ionic solids, they break down and dissolve into the solvent because they're being broken apart into different pieces. Okay? Molecular solids break up into individual molecules, but the covalent bonds holding them together don't break. Okay? Ionic solids often conduct electricity while molecular solids do not. Okay, but this example is a good way to show you how things dissolve and how they're broken up by the solution. When we have solutes in our solutions, it has a tendency to change some of our properties. So for example, when salt is in water and it's trying to freeze, it gets in the way of the crystals that are trying to form, and it actually makes it so it has to be significantly colder for water to freeze when there is salt in it, which is why the ocean doesn't freeze up in the same way that like lakes and rivers do, because there's salt in the way, making the crystals harder to form, which means that they need a cooler temperature. Same thing goes for like water, right? So if you are trying to heat up water and you're trying to boil it, and it has salt in it, the salt is going to get in the way, or whatever solute you have in there is going to get in the way, and it makes it harder for the particles to speed up and then bump out as steam, okay, or turn into those air bubbles. And so basically what's happening is the solute is getting in the way, and it's either slowing down the freezing or slowing down the boiling process, which then changes the properties of that solution. All right, that wraps up chapter 7, section 1, where we're looking at understanding solutions.